Here's another piecewise function. We have f of x is equal to 2x plus 3, where x is greater than or equal to 1, and negative 4, where x is less than 1. So I'm just going to concentrate on one at a time. I'm not even going to think about the other one. So if we have, let's say this first one, it's just like a y equals a 2x plus 3. We want to graph this graph where all the x's are greater than a 1. So again, where all the x's are greater than a 1, I'm going to give myself a nice vertical line at the 1, so I know that I want this graph for everything to the right of this. So 2x plus 3, y-intercept is a positive 3. We go up 3 on the y-axis, put a point, and our slope is up 2 over 1, up 2 over 1, up 2 over 1. So I want to draw this graph just on the right side. All the x's that are greater than or equal to 1 are on the right side of this line. So here's my line. And then what I have to figure out is, will I have a closed circle or an open circle where my line hits the vertical green line that I drew in. So it's greater than or equal to, that gives me a closed circle. So there's that part. Now we're ready to graph, y equals 4 for all of, y equals negative 4 for all of the x's that are less than 1. So less than 1 is to the left of the line. And y equals negative 4. Do we know what that line is going to look like? Hopefully we're recognizing, hey, that's a horizontal line going through negative 4 on the y-axis. So it's this whole horizontal line all the way on the left side of our vertical green line. So we have to figure out, are we going to have an open circle or a closed circle where our y equals negative 4 line hits our vertical line, and this is going to be an open circle because it's a less than inequality. So we're done with the graph. This vertical line that I throw in here, actually you could do without it if you wanted to. I just think it's a nice thing to put in there so you can see. Technically we don't need it in the graph. I just tend to draw it in to help me figure out, am I graphing to the right or to the left. So I have a couple extra questions with this one where we have to evaluate. We have to find f of negative 4 and f of 9. So f of negative 4 means I'm going to plug an x in, or I'm going to plug negative 4 in for the x. The only problem is that we have two equations, so we have to figure out which one do we plug it into. Well, if the x that we're plugging in is a negative 4, we have to ask ourselves, is negative 4 greater than or equal to 1, or is negative 4 less than 1? Since negative 4 is less than 1, we're going to plug it into this equation. So if x is a negative 4, what is the y? Well, anytime we have one of these horizontal lines, that y value never changes. It doesn't matter what the x is, so our answer is going to be a negative 4 right here. We can look at the graph to just kind of confirm that. If I go 1, 2, 3, 4, when x is a negative 4 and I go down to the graph, the y is a negative 4 also. That's the point we're looking for, negative 4, negative 4. The next one, when f of 9, when x is 9, which equation are we going to plug into? So we ask ourselves, we look at the equations again, and our little restrictions off on the side. Is 9 greater than or equal to 1, or is 9 less than 1? Since we know that 9 is greater than or equal to 1, that means we're going to plug it into this equation, just into the 2x plus 3. So instead of the x, I'm going to put a 9, so 2 times 9 plus 3. 2 times 9 is 18. 18 plus 3 gives us a final answer of 21. When we have to evaluate for the function, we just have to figure out which equation does it go into, and we pay attention to this part of the graph to see where does it go into. And that's how we do that.